Hello everyone, our project is object detection, tracking, re-identification and activity recognition for maritime surveillances using thermal vision. Our supervisors are Dr. Pesha Jayasekara and Dr. Ranga Rodrigo. Being surrounded by the sea, Sri Lanka is facing some crucial problems such as human trafficking, drug smuggling and illegal fishing. Although the Sri Lankan Navy and Coastal Guards deploy continuous search rounds, it is really hard to mitigate these activities as most of them are happening at night. It is also impossible to conduct search rounds 24/7 using human efforts. So, we identified the need of an automated system with two main capabilities: re-identification and activity detection. Re-identification refers to the capability of identifying the same boat seen on two different days as a single ID. By doing so, we can maintain a blacklist of vessels that are related to the above mentioned illegal activities. Additionally, we have added the activity detection feature to catch new boats engaged in illegal activities such as drug smuggling, human trafficking, and illegal fishing. We use FLIR M232 Maritime thermal camera to capture video footages. The camera is capable of detecting vessels up to 1.3 kilometers with a resolution of 320 by 240 pixels. First, the video feed is fed to the object detection and tracking algorithm, where we detect and track boats, ships, humans, and jet skis. The cropped frames are fed into the object re-identification algorithm. We extract features using a vision transformer and check whether there is a match in our database. In the activity detection algorithm, we continuously process the video feed to find suspicious activities. If we find any, we will trigger an alarm notifying the authorities. All the resulted video feeds are presented in the user interface for a better user experience. Since there isn't any publicly available dataset for these specific tasks, we had to develop our own dataset from scratch. One of the main pillars of our project is object detection and tracking. We use the TRADIS algorithm, which was originally designed to detect and track vehicles in the RGB domain. After making several modifications, we could adapt this algorithm to detect and track vessels and humans in the thermal domain. We achieved 70.1% motor score with a processing speed of 15 frames per second. So, we could achieve real-time processing capabilities. The next main part of our project is vessel re-identification. This is quite challenging since there aren't any color features in thermal images, and the rest highly depend on the boat's orientation. Our objective was to identify vessels regardless of their orientation. To pay attention to orientations of a boat, we use masks for each visible side of the boat, generated by an encoder-decoder model. We calculate the area ratios of each side of the boat using these generated masks. For an example, this image contains 60% of front and 40% of side views. A vision transformer is used to extract features which are then mapped to 4 separate spaces, namely global, front, rear, and side. We cluster the extracted features in each space using the arc phase loss. When a new boat is detected, we map its features to these spaces and calculate the final confidence considering its orientation. This is done by multiplying the confidence of each space with the corresponding area ratio. We evaluated our method using two datasets and achieved significant results in the thermal domain. The next main part of our project is adapting the Jovo algorithm to detect activities such as human trafficking and swimming in the thermal domain. We successfully completed that stage as well. As the final step, we are in the process of publishing two conference papers.